and without further ado, Butch, take it away. Thanks.
Is it go time? It's go time. It's go time. All right. All right, let's make sure. Hey, I got some claps. All right. Hey, welcome everybody to my talk, Continuous Performance Testing with K6. I want to say thank you to them. They got me this nice t-shirt, and I've got some stickers. So if anybody's like inspired and wants some stickers, just come and find me and we'll get you set up. All right, so let's get this presentation going. All right, howdy. I'm Butch Mayhew. Just wanted to do a quick update from last year. If anybody was here, I talked about Playwright, which is an automation tool I'm a big fan of. It was automating all the things with Playwright. Currently today, we've got 1,300 checks that run at about 12 minutes against our API services and 120 UI automation end-to-end test, and they take about 10 minutes, and it's helped us discover 68 issues over the past year. So I'm pretty proud of that. So I figured, I don't know why that's flickering, but we're gonna keep rolling with it. But if you wanna check out, you can link me and connect with me. And quick update, Playwright, I love it. If you wanna talk Playwright or any quality testing, any of that stuff, I'd love to talk about that stuff too. But that's not why we're here today. We're here to talk about continuous testing with K6. So, let's move on. I'm gonna define performance testing in one slide. It is the practice of evaluating how a system performs in terms of responsiveness and stability under a particular workload, okay? So pretty basic, there's a lot of big words in there. We're gonna talk about what does that look like in real life by starting with the different types of performance testing you can do. So when you think about like performance testing or specifically a load test, I know a lot of different words kind of get thrown around, but the way K6 defines it is a load test is something that's gonna ramp up. It's gonna kind of like go on for about an hour and then come down or some specified time. And it's a lot like this, right? Your system's going, you're still there drinking your coffee, everything's fine. Your system should be humming, right, under a normal load test, hopefully. You've also got the idea of a soak test. And a soak test is something that's, or an endurance test, something that is run over the course of a day or multiple hours. Maybe it's a smaller amount of users, very useful for finding like memory leaks and whatnot. And that's a lot like Forrest Gump, running across the US. So I hope you'll get where we're going here. Now we've got stress testing. This is where you're gonna ramp up, see how your system performs, ramp up again, see how your system performs, ramp up again, pretty much until your system crashes and fails. Hopefully y'all can like imagine the music going on, right? And then we've got spike testing, right? So we're gonna put a lot of traffic into a system. We're gonna come back down, and that's a lot like this guy where it's like, hey, things are good, and it's like, whoa, things are not good, and things are good again, and things are not good. So in the end, right, performance test and memes, there you have it. Hopefully you can get a good understanding of the different types of performance tests you can do. Now we're not going to look at each, how to implement each one of these in this talk, but just know that this is all possible with K6, the tool. So you'll see the different types again, and now you're probably asking like why, right? Maybe you got looking to the side like, man, this is going to be a really long talk with those slow slide transitions. And you may be asking like, is it worth it? Do I need to continue to sit in here and listen? Maybe I get a few memes, that's great, but are the slow transitions and these crazy animations, maybe a few memes, is it worth it? And so let me just like poll the audience. Can anybody guess how long each slide transition took? Just shout it out. 3? 5 seconds, I got it 2 seconds. It is 5 seconds, right? But it felt like a really long time, just kind of like waiting for things to go. And guess what? That's a lot like some of your system's performance. And so there we go. It's on purpose. One thing that each of you have to do when it comes to performance risks within your own context is answer the question why. Like why and what? Like what's good enough? Why do we care about performance if you do? Why does it matter in your context? And I would argue that in the end, it really boils down to what are you willing to put up with, or what are your customers willing to put up with, even if it's slow, right? Nobody's left my talk yet, I hope. Maybe they did, but I think it was worth a little bit of slow performance to kind of prove a point. So my context, I work at a company called Tild. We are PayFac as a service, so we're a payments provider. We provide APIs and tooling for software vendors to process payments with and hopefully monetize those payments as a place to make a little more revenue. And we want to respond really quickly. In the most real way, we are the third party. That third party that you're like, man, this third party's so slow, I wish we could drop them. We are that for other people, and I don't want other people saying that about us, right? So that is why performance is important to me in our context. So we want to respond quickly in the most real way. And so anytime an API call is made into our system, our integrators already have a transaction open. They're waiting for us to go do our work and respond. And in the end, our performance and reliability really plays into the bigger picture of our customers' performance and reliability. So, that comes to the next question. Who, right? When we think about why performance for Tild, I want our systems to perform for who, which is our customers. You get that? You see it? Who? All right. So our end users, our customers, we want them to have a delightful experience making payments through the tools and the APIs. And we don't want to have that negative impact. Again, we don't want people complaining, man, Tild, they're the slow third party that we don't need anymore. I want us to come to us saying, this is a great experience. Things are really fast. It's a great experience. So I can tell you this, as part of this presentation, you're more than likely have more of a delightful experience now that our slow transitions are over. Back to full speed, baby. All right. Oh, did I go the right way? I did. Okay. So in this talk, we talked about the different types of performance testing. This is really more on the, sending a whole bunch of transactions to, services or a web server. But K6 can also do web browser performance testing. So if you see this little blue section that's outlined, you can actually see the output of a K6 run actually provides browser-done content load time, first element to paint. So if you are a UI engineer or you work with UI engineers, those numbers mean something to them and they love them. So just know that K6 has that capability. We're not going to cover that, but it does it, which is really nice. So one of the questions that I start to ask when I approach a new problem or new service that I need to add some coverage or testing around is what areas do I want to test? So for my context, we've got our front end, our page load times, that browser front end test. I don't care too much about that for this purpose. Our application codes are our full system services. You've got different API layers that are layered in there. Maybe you've got some asynchronous services that are happening in the background. Maybe you've got a database layer where you store your data, and there's probably bottlenecks. You've also got infrastructure layer. So what are all of your servers running on, right? Maybe it's in the cloud, maybe it's on-prem somewhere. And then you've also got the network layer, right? How much throughput can we actually send before things topple over? And the things we care about are the things in bold, are specifically for Tild. I care about that API layer. I care about our database layer, our infrastructure layer, and our network layer. So as I started writing tests, this was really our strategy. So it was very focused, and it painted a very clear picture on what kind of test I need to write and what levels I need to write at. If you don't come up with a strategy when you're trying to implement performance testing, you're going to have all these options, and you're not going to know where to start. So first thing I would say is, what's your why? And then what do you want to cover? What are those different layers? So hopefully, if you ever have to design a strategy, think through what does your system look like and what areas do you want to cover, and make that an explicit requirement as you start building things out. So K6, they actually offer a open source version, and they also offer a hosted, I think it's called Grafana Cloud K6. So K6 was acquired by Grafana a little while back, and they just kind of rolled out this new, hey, K6 can integrate with Grafana, and it's a beautiful thing if you're in the Grafana environment. And it costs money, of course, as well. For us, and for our purposes, we actually landed on the open source implementation. So that means we don't have all the pretty dashboards, we don't have the pretty no-code editor, but we were able to kind of accomplish all of our needs using the K6 engine to exercise our test. And just a quick high level, what is K6? K6, I'm going to use the Butch term, so if this is wrong, I apologize, but this is how I understand it. K6 is a JavaScript library kind of wrapper that's kind of wrapped around Go binaries that actually go make all the transactions. So when you're running a K6 test, you're actually not spinning up a node server. It's just kind of taking that and sending all that, taking the JavaScript code and sending it to go make all our transactions. So it's very performant. You can make a lot of requests, even on a single machine, and get a lot of feedback about your system. So here is a short example of what it would look like to run a K6 test. So at the top, that's the command I use to run. And then the bottom is the CLI output and summary. So in this example, we call K6 run. We pass in VUs. These are basically virtual users. So I passed in 10 users for a duration of 30 seconds, and I ran the script.js file. And we're going to look at that file. But if you look really closely, you can see there's a whole lot of information on the screen. So it can be very overwhelming to figure out, okay, we've got our plan in place for what we want to cover. What do all these numbers mean? What do I need to care about? What's important to me and my org? And I'll cover the things that we decided to care about. But before we get there, here's just a quick rundown of the code. Hopefully that's not that's somewhat visible. But in the end, I'll kind of point up here. You've got your imports. You've got some more imports for reporters. All the reporter stuff kind of happens, I think that's down here at the end, the handle summary section. And then this little section in the middle is really the K6 test. And in the end, we are just making a GET call to a URL to one of their test sites. And we actually do a check. So we actually make an assertion to say, hey, is the status you get back a 200, right? A lot of times in performance testing, you throw a whole bunch of stuff at it and you're like, well, the load happened. I don't know if any of them were successful or not, right? So I always encourage you to have some kind of check, either on a status code or a response that you're expecting, just to make sure that it's not just an invalid response or a 500 error or any of the 501s, 502s, 503s, all the things that you can experience with your infrastructure. So this is a very basic test, and this test is available at a repo I have, so you can, after everything's done, you can go download it, install K6, and kind of play around with this stuff. That's how I learn things. That's probably how some of y'all learn things. All right, so if you saw back on the past page, we actually had different summaries. So this is an example of an HTML summary. So this is pretty much, so I can take this HTML file and go post it to a Slack channel or post it somewhere that is not just in a command line in the cloud somewhere. So I found that this is a useful tool to export, but also this is something I can easily share with other people to say, hey, here's how our performance test did today or last week, et cetera. So just a little more context into Tilde and the tools we use and how we built things up. So we use GitHub Actions for our automation for our CI. So on a nightly schedule at 4 a.m., we kick off our automation. And all of our K6 tests are basically bundled up and built out to an ECS task, which are then run at 4 a.m. So we kick off our job. You see this crazy looking Roadrunner. That's the name of our automation tool. All of our products are bird names. You can talk about me later about that if you're curious, but Roadrunner is what we picked. And it's kind of like Load Runner, if you're familiar with that, play on words. So just a quick diagram of what our tests look like. So we've got a suite of basically critical path tests. So these are critical endpoints that we care about. We've written tests around, and we run these tests at 4 a.m. on weekdays. We don't have a super huge load from just our production traffic, but running 10 virtual users for 10 minutes we get a whole lot of transactions and we learn a lot about our system and how it responds under load. And like if we had more production traffic, like we would definitely kind of up this number, but pretty much we're making 10 payments every second, and that equates to a lot of API calls. So here we actually kick off to our Slack notification. So this is kind of like our check-in. Hey, how did the test go? That posts to a Slack channel, and each of our different tests, we actually report out these metrics. So the ones we care about are max throughput, the amount of HTTP failures we had. So if a check failed, we would know that there. Our average response time, and then our P95 response time, along with how many virtual users ran and how many iterations completed. So actually, like when I first saw all that stuff, I was kind of like, what matters? What do I need to care about? And I determined that iterations was actually a pretty key metric we could do, because I'm running the same test at the same time for the same duration. So if the iterations went up or down, that would tell me that my throughput has gone down and be a pretty good indicator of if there were issues with our system. But there's other things we track as well. But that's an example of our Slack notifications. We also, because we're automating all the things, I don't want to have to go click buttons or go look at things every single day. We automated a lot of the reporting out of this. So that's what made it continuous and what made me not lose interest, because some of just clicking buttons and merging reports, that's boring stuff. But if I can automate it, that makes me happy. So down here, you can see we are actually exporting our results to JSON. We run some bash magic to get some JSON, and then we send it to CloudWatch, which then sends it to Sumo Logic, which we then built a dashboard. This is pretty much how all of our CI stuff is, right? You just kind of glue stuff together and it works. And then we alert off of Sumo Logic dashboard. So if there is an issue, we're going to get a PagerDuty alert and we're going to go investigate that. So now I don't have to think about it. It will just magically tell me if there's an issue, which is nice. So this is an example of our Sumo Logic dashboards. In each of these things, I know these are super tiny, but we're tracking the same things you saw in the Slack message. What's the average response time? What's the failures? What's the number of iterations? And this is just a quick way to see, hey, is all of our system performing, or just specific endpoints? So each of these boxes is a different test, and each test are hitting either different single endpoints, or down here, we're actually making multiple API calls as automation flows, where it's 2 or 3 steps. So this is really useful to kind of investigate what are the issues, how has it looked, what's the trend look like. And really, in this scenario, we're only tracking, there's only, I think, five points that we track every single day. So we take the summary, we parse all that stuff, and then we send 5 metrics a day for each of these endpoints, and we get these nice, pretty graphs. And then for our alerting, we use Sumo Logic, and they've got a nice little alerting feature where you can establish, hey, I think this is specifically our average response time. So if our average response time is over 500 milliseconds, we're going to send out a PagerDuty alert. So you can see back on March 24th, we had a PagerDuty alert. Our systems were wonky. We looked into it, not really sure what happened, but everything's good because everything's back. So, all right. So these are the metrics we graph and we alert on. Again, average response time and iterations. Those are the two that I found really helpful, right? If our average response time goes up, we should look into it. If our iterations go down, we can't complete as many, I'm going to alert on that. And we're going to go investigate and figure out, was there a new code change? Did we forget to put some indexes in the database? Lots of different things. All right, so just some quick advice. If you ever need to create a performance testing strategy, decide when you want to run your test. Decide what environment you want to run your test against, right? The closer production it is, the better, depending on your context. Decide what type of test and how many users and how much time those tests should run, and run your test to get a baseline. So to establish those baselines, we basically ran our automation, I guess, for about 2 weeks. We kind of saw what is the baseline, what are the trends, and we came up with what are those outliers we want to be notified on. And then create alerts. And when you change things or you update a test, make sure to go create a new baseline, or else you're going to probably get alerted, because that's how things work. So some pretty cool features that really drew me to K6. So right now we're running with a pretty small amount of virtual users, but knowing just that we could scale with this if we ever needed to with the same code that I've already written, made K6 the choice for me. But these extra tools actually help make it just really easy to get started. So they've got an open API or Swagger to K6 script generator. This is a generator. It's going to take whatever you have an open API spec and try to write the code for you. It's not going to work unless your open API spec is amazing. You're probably going to have to modify it and adjust things to set up test data or things like that. But I found it really useful for just taking our open API spec, dumping it out, and generating a quick list of tests to get started. And then I cherry pick from there to build out our repo. They also have a Postman to K6 script. So that's really useful if you have Postman stuff that's built and that's organized well. They also have Harfile to K6 script. So if you've got some network traffic that you're like, let me just replay this, you can convert that to a script. Will everything work? Probably not. You're going to have to go work out authentication, work out any specific test data you need against whatever environment you're running against. But for the most part, it gives you a template, which is really nice. All right, quick time check. Let's see where we are. Okay, we're doing good. Doing good on time. All right. So just some quick updates around another reason we chose K6 as a tool. They do have Grafana Cloud K6. It is a paid service. But what's really nice about that is, you don't have to worry about, tying a bunch of systems together to get your metrics somewhere to alert on it. You can build that right in the tool. And there are different, levels you can buy if you want to run 100 virtual users. There's different payment, things you can look at. But all that stuff's managed. You don't have to worry about, building your own ECS cluster to run your tests or having a developer run off their machine. All that's in the cloud. If you don't want to worry about it, you can pay for it, which is great. I love options. This is an example of the graphs that you can actually see within the K6 cloud implementation. You can see this was just like a quick test that I recorded with the browser recorder. Okay, so this is like a really cool pro tip. I think you can sign up for a free trial and generate some free scripts, but the idea is you can get this browser recorder, install as an extension, hit record button, go do some things in your app. It's going to capture all that network traffic along with all the assets and whatnot. And it's going to give you a WYSIWYG to say, all right, import that test in. And now you can go take out the things you don't want, parameterize different things, and set sleep durations or whatever you want. So very customizable. You can kind of use this with the open source. You just kind of have to free trial it and import it in and all that. Hopefully that's okay to say. It should be. It's all good. All right. And then in the K6 Cloud, they also have a low-code recording management platform. So maybe you hate JavaScript. And you're like, I don't want to work in JavaScript. That's not for me. It doesn't do TypeScript. Well, I think it can, but there's some community things that's been done. But you can manage everything from the console as well. So if you go the paid route, or there's a little toggle up at the top. You can take whatever has been modified, convert that to your script, copy and paste it, and now you've got the code to run in your own hosted environment. So really useful tools that they provide that make things just go a lot quicker than if you had to do all this by hand. And through the cloud version, they also have ways to integrate to make the ultimate dashboard. Now you can, integrate with Datadog or Grafana Cloud or New Relic. Integrating to that will allow you to take basically your performance metrics, which is more than just my summary points. They're going to bring over basically the ramp time. It's going to look a lot like, whoops, we're not there yet. It's going to look a lot like this. kind of in those other APM solutions. And you can look at that graph along with your server resources. So as your stuff ramps up, you can see right next to it, hey, are the servers humming? Are they kind of maxing out on CPU? Is this database okay over here? You can see all that stuff in one view, which is really, really beneficial. And it's, click of the button and a couple commands and everything's configured. So it's pretty nice. So that's all I got. I found this to be a really, really useful tool, and just to give me and our team feedback about how our systems are operating and whatnot. So I would say if you can take a picture of this, there is a feedback link in that picture that I would love to get just feedback on my talk, if it was helpful, if it was not helpful. So I would appreciate that if anybody's willing to give that. And that's all I got. Anybody have any questions? Oh, buddy.
Sorry about that.
Do you know if there is a maximum amount of virtual users and time for your tests that you can use with K6?
If you're on the cloud version, it's whatever you pay for. If it's on your own, it's whatever your hardware can pump out of its network ports.
Okay, thank you.
You're welcome. You can run it distributed as well. So if you have a K8 cluster, there are ways to say, hey, go spin up multiple runners and manage it from there. All right, yes.
Yo. Do you run your tests in prod?
I don't, because it's payments, and I don't have a credit card big enough.
All right. And I guess, how do you decide what your performance goals are?
Yeah, that's a great question. I ask my CTO, what do you want it to be? So, in the end, right, ideally, our APIs should finish processing in less than a second, right? So that's kind of like, we're doing okay, but a lot of our APIs, we rely on third parties as well. So again, we have the third party problem as well. As we're a third party, is we have downstream payment rails that we have to interact with and wait on. So some of those are very difficult. I think one of our future things we want to do is mock our payments, so we can run things in production and basically mock, send some fake traffic. But that would allow us to really drive down what are the things we can care about, what are the database calls, and just have no third-party interactions. But that requires us to modify our code. So we're in the process of that, actually. Maybe next year.
If you would decide to start from scratch, would you pick K6 over low-cost, and why?
Okay, so I will say I would pick K6 because I know K6. But here's the deal. Like, a tool is a tool. If there's a tool that can get a job done, I'm not going to say, like, K6 is better in all these ways. Like, there's probably a lot of ways Lotus is better. Lotus is JavaScript, or is that Python?
It's a Python.
Python? Yeah. I mean, if I had a Python shop, I'd probably pick that. For the most part, a lot of our devs are building things in TypeScript. So that's one of the main reasons we kind of looked in that column of tools. But you're not going to hear me say, like, these tools are horrible. Like, no. Actually, a lot of them serve the same purpose and can accomplish the same goals you need. So I skipped your question, but yeah. Yes.
How often do you find that there's scenarios in prod that you just didn't mock correctly in your load tests and have to go, and are you able to mock those scenarios, or are there just some that you just can't match reality for?
Yeah, so specifically what we are doing, so our production has a lot of asynchronous jobs that happen where we take files that are ingested, from our third parties and do certain things. Like, I'm not focused on those things, but specifically for our API calls, I haven't had any issues mocking those. Now, we do rely on test cards, so I can't test every single credit card, right? I've got a limited set of test cards I can run against. But for the most part, that hasn't been too big of an issue. I'll also say like our staging environment where we run our performance tests matches up to production. So we're running on the same hardware, so we really haven't seen, with high confidence, I can say, hey, we can handle this type of load, whether it's spiked in or over time in production with no concerns.
All right, any other questions? All right, a big round of applause for Butch. Thank you so much.